Hi, everyone. Welcome to the webinar. I think we'll just wait another minute to see if some folks trickle in before we get going. Okay, it looks like we still have a few people joining in. Guess we'll give it another 30 seconds. All right, let's kick things off, and as others join, they will be able to follow along, so I'm sure. Thank you to everyone for joining today's webinar to learn a little bit more about what is coming next for the Sofar Ocean Smart Mooring in particular. My name is Nevin DiParlo. I'm our commercial business manager focused on device and data sales globally. I am based in Boston, but of course our headquarters and production facility are out in San Francisco on the West Coast. This recording will be made available after the fact. In addition to that, we will save a few minutes at the end to ask questions. Feel free to drop them in the chat and we will be sure to get to them at the end and we'll leave plenty of time. So just before we dig into the smart mooring and really what's coming next, we'll talk a little bit about Sofar Ocean at a high level. So Sofar Ocean is an ocean intelligence company headquartered in San Francisco, California. We're a team of about 80 engineers, business professionals, and scientists who are all on this collective mission to connect the world's oceans to power a more sustainable future. Some of you may have heard part of this presentation before, but the reason we're on this mission is because there's a data gap that exists in the marine environment, both nearshore and offshore, because sensors really just aren't designed for scale. They're big, they're expensive, they're difficult to use. And we're fundamentally changing that with small, rapidly deployable, easy to use ocean IoT sensors that are accessible and scalable. And so on this animation here, what you're actually looking at is our global network of open ocean drifting spotter buoys that are persistently collecting marine weather data 24/7, 365, sending that data up to our cloud, which we then use to improve global marine weather forecasts. And that's really the foundational hardware that enables us to support research, industry, and government all over the world with more data in the marine environment. So for us, everything really starts with accessible observations. As I mentioned on the last slide, there is a data gap that needs to be filled, whether it be in lakes, in rivers, or in the ocean. And Spotter and Sofar Ocean hardware and sensors are able to make these observations significantly more accessible due to their ease of use, their cost, size, and everything that really goes into scale. And when we think about the different types of sensors and buoys specifically that are available today, the reason why we are sort of on this mission to close the ocean data gap is because traditional solutions, as I mentioned previously, are very large and very expensive, ranging anywhere from like your typical 3-meter Met buoy down to a smaller data well wave rider. But then, of course, you can see how much smaller a spotter really is. And I actually can hold one up on my screen too. I'm not sure if everyone can see this, but this is a real life spotter. This is what it looks like. And so when I mean it's small, it's easy to handle, and it's rapidly deployable, we do really mean that. And at Sofar, we really like to focus on the spotter not just being low cost, but still maintaining high value. So although it's not necessarily a one-for-one replacement for a more expensive buoy, it is able to do almost everything to the same degree of accuracy, especially all of your traditional wave rider, wave buoys, and also collect significantly more data, improve spatial density for projects that typically, either can't get funding at all to deploy any observation systems or just don't have enough to build a network. So the spotter itself, as we've mentioned already, is a small, low-cost, rapidly deployable smart buoy and marine weather buoy. It's a $6,000 system, so it's about the 10th of a cost of a traditional solution. The data is extremely accessible, and when we mean accessible, it's available through either a dashboard or an API, and data is sent to the cloud over either Iridium or cellular, which drastically reduces transmission costs, of course, if you're near shore, allowing you to send more data at a lower cost than ever before. The spotter is entirely powered by the sun, so there's minimal maintenance. You don't need to swap in and out batteries. Even at high latitude, spotters are designed for persistent operations, and the solar panels are able to consistently recharge that battery so you get the observations that you need at all times. In addition to that, we've deployed thousands of spotters all over the world. We've airdropped them into hurricanes. We've deployed them for winters in the Arctic. And we've deployed them through massive Southern Ocean swells, and they are really ocean proof. And as I mentioned before, even though these are small, low cost, they are not low in value. They're extremely high in value. They're extremely reliable. And we've collected tens of millions of ocean hours to prove that. And then most importantly is we not only break down the barriers of cost associated with ocean sensing, but we also break down that barrier of complexity, which is really critical. So spotters are very easy to use. We've had hundreds of them deployed by completely untrained personnel, from surfers to citizen scientists to engineers with no marine sensing backgrounds. And this is why we're able to cast a wider net and collect more data in all marine environments with the spotter in the smart mooring. So now to start to transition away from just the spotter at the surface and more into the subsurface environment, which is where we're going to focus most of our time, the spotter was really designed to break down those barriers of cost and complexity at the air-sea interface. Well, what we realized quickly is that subsurface sensing and data collection is even more complex and even more difficult just in general, especially when you're trying to build real-time systems. So what we did is we created the subsurface extension for the spotter in the smart mooring. And the smart mooring is basically a power and communication mooring system that's also load bearing that connects directly to the spotter and allows our customers and us internally to integrate different sensors below the surface so that we can build surface to seabed intelligence systems that are delivering both the surface data from the spotter and subsurface observations all to the cloud and accessible through the same API and dashboard. So this is creating real-time, rapidly deployable, still low cost, still easy to use, full water depth solutions in coastal environments for collecting data at the surface all the way to the seabed. And this has been something that many of you are probably familiar with. Some may even be customers of the spotter and smart mooring with integrated subsurface temperature sensors or bottom-mounted pressure sensors, which are the two configurations that we have offered for the last few years, where you can have either up to 3 inline temperature sensors on the smart mooring or a bottom-mounted pressure sensor to look at relative water level. And those have both been either an internal Sofar temp sensor or RBR CODA series temperature or pressure sensor for those of you who are looking for a higher accuracy solution. And just this year, we are now really expanding this ecosystem with 2 new configurations that we'll talk more about in just a minute. So as many of you know on this webinar, marine systems integration is extremely complicated, it's extremely messy, and we feel that it really shouldn't be. This is one of the big reasons why ocean data collection is really not scalable today. The barriers are just too high in the sense of both cost and complexity, which is why we created Bristlemouth, which is going to be launching later this year in Q2. And this really enables simple marine hardware integration, especially compared to systems that are on the market today. What Bristlemouth ultimately is at a high level is a universal open connectivity standard that provides plug-and-play functionality for marine hardware systems. So this will both allow system integrators and OEMs to deploy rapid solutions for different sensor integrations on smart moorings, whether that be for testing or for operational use in the field. So what's coming next with the smart mooring? Well, quite simply, we have 2 new configurations that are going to be released at different points this year. In Q2, we will be releasing a dev kit smart mooring, which is essentially a developer kit that's powered by Bristlemouth that will allow users to purchase smart moorings and developer kits, of course, with those smart moorings, to integrate sensors of their choosing on the smart mooring faster, much more easily, and at a much lower cost than ever before. So again, this is really going to apply to both system integrators and researchers, as well as OEMs who want to start integrating sensors using Bristlemouth or testing those sensors in real time using the smart mooring. And then the second piece of the smart mooring extension that we can talk a little bit more about today is currents. As you know, with the spotter, our focus has really been waves and marine weather at the surface. Currents are really that next step in physical oceanography that we have seen a lot of demand for over the last few years. So we will be integrating a single point current meter on the smart mooring that will be available likely in Q4. That timeline is still being worked out. It's for the exact release date, but it is coming and it is being worked on, which is really exciting. So to talk a little bit more about the specs and what will actually be available with these two smart mooring developments, we can start with the integration kit or the developer kit, which again is really designed to make integration easy for end users. Whether you be an existing smart mooring customer and you want to integrate a sensor that you already own, or if you're designing a sensor and you want to use Bristlemouth and integrate it on a smart mooring to collect real-time data, the developer kit is for you. We are making it a goal to be able to support all levels in sort of the customer journey, whether you're really experienced with coding and system integration and marine deployments, or if you're new to everything, you don't have a lot of coding experience and you don't have a lot of deployment experience in marine environments. The smart mooring with an integration kit and development kit is for you. And we will make a very easy step-by-step guide that will enable users at all skill levels to take advantage of Bristlemouth and to take advantage of the functionality that a smart mooring enables in collecting coastal data below the surface. So this is really exciting. Here are a few technical specs we won't go over in detail, but I would urge you to reach out with questions and we can set up specific meetings to talk through sensors that you want to integrate or specification limitations, availability, etc. I'm happy to talk to any of you. We have a sales team that is very responsive, and we would love to also speak with your engineers and also connect you with our team on the product and engineering side as well to learn more about your needs. I can always pull this back up at the end too, and we will of course share this presentation if you're interested in looking at in more detail. So for currents, I mentioned on the previous slide that this is really our extension into the next parameter in physical oceanography that we really want to focus on. These will be single point current meters. There's been a lot of interest in being able to mount single point current meters in line on smart moorings for the last few years. And so we listened and we're going to deliver. Here are some really high level specs. Again, these are not finalized. And I would push you to reach out to us if you're interested in having some input on the final specifications, or you're interested in what we're going to be able to offer specifically around being able to measure single point currents with the smart mooring. We would be open to speaking with anyone on that front at any time. But in general, the smart mooring with currents is really that logical next step for us to be able to deliver a new system that meets the needs of lots of customers who are already interested and excited about using the spotter for research or operational support, where currents can have a really big role in both the end result of studies, but also in operational support for industries like offshore wind or aquaculture. So we're really excited to take this next step with the smart mooring. And again, currents are going to be unlocked towards the end of this year in Q4. So before we wrap things up, I always like to tie it back into why Sofar really exists, right? As I mentioned earlier, there is a massive data gap in marine environments. That's not just at the surface, that's not just with wave buoys and marine weather buoys in general, but even more so that is below the surface. And what Sofar does is we unblock these barriers of cost and complexity associated with ocean sensing. The spotter is extremely easy to deploy. We will continue to develop its capabilities at the surface, but even more importantly, we will continue to develop the capabilities of the smart mooring below the surface so that we can collect more data, allow OEMs and integrators to more easily integrate their sensors on the platform. We really want to create this open standard ecosystem in the marine sensing space that will allow us all to develop new technologies faster and to deploy those solutions faster. We really can't change anything that we can't measure, and that's why we exist as a company. Here are a few examples of spotters being deployed just to show you how easy they are to use if you have not ever seen or used one before. And we're really excited to continue to evolve this ecosystem with the smart mooring, with both the integration kits and also subsurface single point currents available on the smart mooring later this year. As a company, we really recognize that we live on planet ocean and we need to have an impact altogether. So you typically find us having this impact in the world of conservation, that be focused on monitoring coral reef health and coral bleaching events, extreme weather, and being able to better understand, measure, and predict extreme weather events and hurricanes in particular. And then, of course, emissions. We recognize that cutting back on carbon emissions is critical, and we use both our data and our forecasting to try and help the maritime industry do that with data-driven insights. So this is why we really exist as a company. I'd be happy to take any questions. I'm sure there are some that have come through in the chat, but feel free to just drop them in the chat and we can get to them as we go. And also I push you to schedule a meeting with me if you'd like to talk in more detail about specifications or specific needs for some of your upcoming projects based on the new releases in the smart mooring ecosystem that I talked about today. Thanks. Don't see, oh, here we go, one question. The current meter would also give direction, so it'd be speed and direction. And again, if you do have questions, just drop them in the chat window. If not, my contact information is right on this slide, both my phone number and my email. How deep the mooring line can go. Yeah, so in terms of the depth limitations on the smart mooring, right now, we limit it to 50-meter depth. So primarily for shallower coastal deployments. The baseline pricing for a moored configuration with 3 temperature sensors. So for 3 inline temperature sensors on a smart mooring, depending on the water depth, you're likely looking at a minimum of $10,000, but I would push you to reach out to me directly for a quote. So the Bristlemouth development kit is going to be available towards the end of Q2, but we will be taking some pre-orders for that kit in the beginning of Q2, so probably starting next month. And again, would push you to send us an email so that you can get on that list. Just looking through a number of questions coming through. So how can the data be secured and not available for public consumption? So we do not make the data available for public consumption already. You can keep that private to yourself. Looks like we have one question about our global network. How do you recover the units after deployment? So if the units are moored, you would recover it the same way you would with a standard mooring system. Just of course, you don't need as many resources, typically a smaller boat, fewer people, less lifting capacity, just because the system is much smaller and easier to handle. In our open ocean units, the most common failure mechanism is beaching, and we work with local partners and customers in those areas to consistently recover and redeploy the buoys. Oftentimes, we actually let the recoverer redeploy them and keep the data for themselves, or they send them back to us for disposal or refurbishment. We have GPS locations on all spotters at all times, and we have a team that's constantly monitoring the status and location of those buoys in the network. Have you coupled to wireless remote subsea sensors using acoustic telemetry? No, we have not internally, but that is one of the things that we really hope to see develop with Bristlemouth. You could absolutely integrate acoustic modems to the smart mooring using Bristlemouth in the development kit to send data. So again, please reach out. We would love to set up a meeting with our product team and tell you a little bit more about the technical specs. Yeah, for more specific system integration docs on the development kit, Kim, those will be available likely towards the middle of Q2. And we can definitely send them over to you if you shoot me an email after this. The current meter is not going to be developed by Sofar. We will integrate a third-party sensor from another vendor. Yes, you can absolutely use acoustic releases on the smart mooring. When will bidirectional comms be available to allow instructions to aquaculture systems in the ocean? So there is two-way communication available on the smart mooring, but you would have to have that sensor integrated on the smart mooring. So I'm not sure exactly what you're looking for there, Christopher, but would love to learn a little bit more if you want to set up a meeting and reach out to me directly. Spotters are always purchased. We do not rent spotters, Morgan. When moored, how do the buoy handle high currents? How do you avoid being dragged under due to the small size and buoyancy? Yeah, so currents, just like with any system, are difficult to deal with, especially in high current environments. Typically, we just recommend adding additional buoyancy and making sure that we understand the critical maximums in the deployment site or at the deployment site throughout the course of the year, so that the mooring system is designed with the proper strength needed to resist those currents. But drawdown is a concern. What problems do you have with biofouling? Yeah, so biofouling is unfortunately something that no one has solved in altogether. Typically, we just recommend routine maintenance and cleanings, just as you would with any other buoy or sensor, to make sure that the hull of the spotter stays clean and that biofouling doesn't grow up onto the solar panels. But this is something that our customers have really done a great job at combating with proper maintenance intervals, and we see their ability to keep spotters deployed persistently for a long time, 1 year plus, without any issues. How the mooring gets compliance of extreme weather. I'm not exactly sure what that question is asking, but the smart mooring is designed to sustain through extreme weather events, as we do deploy these ahead of hurricanes as well. So we just recommend proper preparation, ensuring that you have a sufficient anchor weight if you are expecting severe conditions. And again, would recommend that you consult with us before deploying a spotter or smart mooring so we can help you understand these limitations. Do we have any data quality assurance protocols? Yeah, so we actually have a full packet on our website that provides a technical overview of all of the processing capabilities of the spotter. So we can happily send that over to you, Jennifer, and we can also happily set up a call with some of our PhD oceanographers who are involved in developing the algorithms on the spotter to ensure proper quality control and reliability. But we've deployed spotter and published multiple scientific papers next to existing solutions of ADCPs or other wave rider buoys to show that the spotter's data quality is equal to, if not better, than those existing solutions through all conditions. Still have a couple more minutes for some more questions. Okay, well, not seeing any other questions come through. So, oh, looks like we have one more. Can you distribute the presentation we just made? Yeah, the recording will be made available through MTS. So this will be sent around after the fact if you're an attendee. And if you'd like to set up a call directly, again, please send me an email. We can do so, and I'll walk you through the presentation again, and we can talk in more detail. Rob, it looks like you had one other question that I missed. Does the current meter account for motion of the mooring? This is something, we haven't selected the exact spec on the current meter yet, so I'd recommend that we reconnect separately and we will discuss this. Great. Well, I think that's it for questions. Thanks again to everyone for attending today. Again, my contact information is here, and MTS will send it out as a follow-up along with the rest of the slides in the recording. Please reach out to us. We're really excited about what's coming next with the smart mooring, and look forward to connecting with you all and learning about potential use cases soon. Thank you.